Hello and welcome to another Coding Geeks. I'm Gizmo and this is
Amir.
And today we are doing some Java for beginners. We have created a class for our experiments. Maybe just look at the code and copy it. The first thing I want to tell is that Java is an object-oriented type-safe language. This means every variable has a type and the type cannot change during the program runtime. For example, we have in line 3 a method named main with a return type of void. Void means nothing. It does not return anything. It has one parameter or one argument named argv of the type string array. And the first thing we are doing now is line 5 new. We define a variable on the stack. You type int space, then the variable name, maybe x or demo, yeah, demo, and we initialize it with equal and then a number. So this is a statement which declares a variable named demo of type int, which means integer. It's a whole number, a natural number, and we assign it the value 4. So line 6 new, print out the value of the variable with system out. Yep, now round brackets. And you can give the demo, you can put the demo in there. Save and run. Print is a 4. So with variables, you can do computations. That's all a computer does. It's computing numbers. Maybe line 6 new. Demo equals demo plus 1. And what do you think is the output?
It will print hello world, then 5.
Run it. You have in line 4 you print, and in line 7 you print. And line 5 and 6 are just computations. It's not printing the 4 because you just assign a variable. The print is done via system out print line.
Okay.
So it prints only the 5. Okay, so the int is a primitive variable. A primitive means this is not an object. There are other primitives like line 7 new, boolean. Yeah. Boolean b, maybe name it b. B equals true. A boolean is also a primitive and it can either be true or false. And maybe line 9 new, print out the b. And run it, please. Okay. And now in line 10 new, do b equals demo. Semicolon. And line 11 new, print out b again. And run it, please. Oh, an error. Please read out the error message.
Says here, type mismatch, cannot convert from int to boolean.
You cannot assign a variable from another type. So b is a boolean and demo is an int, and you cannot put an int into a boolean. It does not work. But maybe in line 10, we now try to cast demo to a boolean and do round parentheses, normal parentheses. Yeah, exactly there, open and close. Yeah, and that type boolean inside the parentheses. This is called casting. Now you are casting demo to a Boolean. Let's try out if this works. Does not work. You cannot cast an int to a Boolean. Interesting. Okay, then let's try remove the Boolean cast. And before the semicolon, do b equals demo larger than 0. Yeah, and this is a comparison, and this comparison returns either true or false, and this works. Now it should print true 2 times. You see, this works. b equals demo larger than 0. You will soon or later get used to this. Okay, so now we kind of casted the int to a Boolean, kinda. Okay, there's integer, there's Boolean. Another primitive type is char. Line 11 or line 12 new. Char C. C is a variable name. Char is a type. C equals. Now single quotes. You can define characters with single quotes, single characters. Now pick one letter or number or something, one letter. Now you have created a char named C with a value of X. Now print this value. Yep. It should print X. You can run it. Yeah, it works. Now you have to know a char is just a number as well. A char is in theory, it's just an int. It's just an int in theory. And I think you can cast chars to ints. Let's try in line 13 new. Do another integer. Name it C2 equals C. And now print out C2. And try to run this. You see, you can cast a char to an int. This is not a problem. With a Boolean, we had problems, but you can cast a char to an int. The problem with a Boolean is that that there is no real definition in Java what is true and false when you have an integer. In C, it is 0 is false and the rest is true. In Java, it's not defined. You cannot cast it. But a char casted to an int is possible. In line 14, you print the int, and this is the ASCII value of the uppercase X. So you can cast a char to an int because a char is 8-bit, and an int it's 32 bits in Java. Line 14 new. Long is another primitive type. Space, give it a name, equals any number, and maybe print it out as well. And please try line 15 new. D equals C2. Semicolon should print 88 again. And now line 16 new. C2 equals D. Yeah, because you can cast an int to a long because long has enough bits to store it, but you cannot cast a long to an int because int is too small. It's only 32 bits. But you can force it, I think, if you try to cast it to an int with a parenthesis. Before the D, do round, open, and close. And cast it to int, in Klammern int. Yeah, try this. This works again, but this is it might be that it does not fit. Give the long D line 14 D equals 0x ff 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 ff. So these are 32 bits. Now 1f. Save. Print an uppercase L now. Uppercase L. Yeah, for long. Okay, Java sucks. You need, if you have this, those are more than 32 bits, and if you have such huge numbers, you need to put an uppercase L at the end, so the compiler knows it's a long. Now run this. And in line 70, print C2. Line 70, print C2. Comment line 15. Run. Yeah, and this is completely wrong because remove 2 of the Fs. Remove 2 of the Fs. Run this. Yeah, this is quite huge number, and if you put 1 F more, this should be -1. And now put 3 more Fs. Still -1. And now line 17, print the D. You see, the casting in line 16, where you cast D to an int, just says -1, it's wrong, because your number was too huge and yeah. Okay, so those variables are called primitives. Let's introduce functions or methods. Make a new public static function, public static void myfunc. Yep. Now function name. Yeah, perfect. And now round parentheses. And we maybe take an int as parameter. This is first parameter as a type is int, and the variable name is test or number num. The semicolon is wrong. You need round curly braces. Yeah, perfect. Enter. And maybe do system out print line num mal 2, num multiplied by 2. So this function takes a number and an integer and prints out its doubled value, num multiplied by 2, num mal star 2. And in line 18 new, type the function name fname, and you call a function with round normal parentheses. And the function has one parameter. You give it a number, an integer, an int. You can either put a number like this, or you can also give C2 maybe, or C or D, anything that has the correct type. Yeah. With D, the problem is maybe do D. There we have the problem again, this D is a long, and we had to cast it to an int, and it can overflow, but semicolon in the end. And maybe give the D, maybe run it. Read the error message.
It says the method fname int is the name in the type demo is not applicable for the arguments long.
The D long is not correct for an int, but you can cast it again to int or give it the C2. Yeah, you can cast, yeah, C2. This should work. Run it. Fun thing, C2 is -1 in line 16, and the double of -1 is just -2. Questions so far?
No, that's good.
Okay. So now let's create a new file.
What do I call it?
Calculator.
Take the start from here.
Yep, needs a package.
You need the class here.
Yeah, and the class name has to be the same as the file name. Okay, so now let's introduce attributes. A class is a collection of variables and functions, methods. Maybe in programming you say a method is a class function and the function is without a class, but in Java there are only methods, but you can call them functions. Let's call them method because it's more correct. So let's introduce attributes and methods. Maybe in line 3, private, int, left, maybe as variable name, left or a, name it left, semicolon. Then you make line 4 private int right. And line 5 new, a class is a definition. And if you create an object of a class, it's called an instance. And this is like a physical thing. A class, this is a definition you're writing. And maybe just type line 5 public space calc. Round parentheses. This is a function now, a method. This is a method. And maybe make it two parameters, int L and int R. It will hopefully make sense soon. Int L, comma. You separate by comma, yep. Int R. Yeah, the semicolon is wrong. This is a method. You need curly braces. Yep. And this method is exactly called as a class name, and it has no return type. This is called the constructor. And in this constructor, we will say left equals L, semicolon, and right equals R. Yeah, semicolon. Okay. And now we go to demo Java. Save it. And line 19 new. Calc is a type. The type is calc. It's and name it C3 or something, or calc, name it calc. Calc gleich equals new calc round parentheses or press enter. Yeah, 1,3 and semicolon at the end. Save it. So what's happening now? You are creating a variable of type calc, which is then a so-called object, and you create the new object with the L and R parameters. You defined it in your calc object class that you need 2 integers as parameters. So, well, it's a variable of type calc named calc, which is a new calc. Now go to calc Java again. And now line 9 new, public int. It's a method named add, round parentheses, no parameters, now curly braces, and return left plus right. Okay, go to your demo Java. And line 20 new, system out print line. We print calc dot add. Yeah. So what do you think is the output of this line?
No idea.
Run it.
Okay.
So please hover the add and press hold Control and click add. Bam. Okay, this works. What's happening here? So you're creating a calc object, and the calc object needs 8 bytes, 4 bytes for left, 4 bytes for right. in the constructor, you copy the parameters into your left and right variable. And in line 9, we define a method, and the method just returns left plus right. Maybe create a function, a method named subtraction or sub, and implement this. This is our calculator. Please implement a method named subtract, which does left minus right. So same as add, but with a minus. Now you have two methods with the same name and signature. Both methods are named add. Yeah, I would name it sub. Now this class has two methods, or three if you count the constructor, 3 methods with constructor, and 2 attributes. Now go to demo Java. Okay, so the difference between the primitives like long, int, char and your calc is that calc is an object, and if you pass objects to methods, you pass them by pointer or reference. Go to calc Java again. We make a new method, public void. And call it setLeft. I would write uppercase L. This is called camel case, and this is kind of standard. And we have one parameter, an int, and name it freely. Maybe name it left. Name it left. And I want line 16, delete line 16. Or line 60 are deleted and new. We now want to set the attribute left to the parameter left. And what is the warning, the curly warning? Exactly. So now the problem is the parameter is named exactly like the attribute. And now it thinks you want to set the parameter left to parameter left, has no effect. And to distinguish, you can use it to distinguish this. You need this dot left equals left. In line 60 in the start, this dot. And this is a pointer to the current object. Save it. Go to demo Java. Line 20 new. Calc. Dot. And you see this is the same. This is outside of your object. You say calc dot. It is for the calc object, the calc variable, the object. And inside the object, this is the same. This is the current object then. It will make more sense later. Okay, we do calc set left. 3. Let's run it. So in line 19, we create a calc object with left 1 and right 3. In line 20, we set left to 3. And in line 21, we print the result of add, the return of add. Make a new method, line 26 new. Maybe one thing, static. Static means the method works without an object, without this. For static stuff, you do not need objects. It's all static. You have no this, no objects. And without static, you need an object. Also make a new static method. Name it increaser, or ink. Yeah. And in line 27, num equals num plus 1. Not printing, without printing. Yeah, without the print line. This is just a function. It increases the number by 1. It does not print. Yeah. So, okay, line 22 new. Int I equals 1. Next line, call increaser in Klammern I. with I as parameter. And I as parameter, semicolon. And next line, print out I. Run it. Yeah. And this is because if you have a primitive, like I, the number, is the primitive int. If you call methods with a primitive, the primitive value is copied. So the line 30 does nothing because num lives only in the increaser scope. The variable num is only alive in line 30. You call the increaser with I, then it increases I, but it's just a copy and nothing happens. So if you have primitives, the value is copied and is not a reference or something. And let's create a new public static void method. We will use the same name, but we give it a different parameter. We give it of type integer with uppercase I. Parameter name, you choose it, num is fine. Then you need the function braces, curly braces, and the semicolon is wrong. And so the class integer is also a class. Int is a primitive type and integer is a class. The same, num equals num plus 1. And now line 25. Integer is uppercase I2 equals 1. Now call the increaser with this value. Call the method increaser. Call it. Yeah, and you call with round parentheses with a function call. And call it with parameter I2. And line 27, print I2. And run this. Line 36. Delete this line. Do num plus equals. Try this. Num plus equals 1, semicolon. Run this. Rename the method. Increaser2. And now run it. In line 26, call increaser2. And now run it. Still not working. What I wanted to show you is that integer is an object and the parameter integer is passed by object reference and not by primitive value, but by object reference. Okay, let's do a new method, public static void increaser3 and calc parameter and num.setLeft, called setLeft, some value. And now in your main method, maybe clean up the mess a bit, delete everything of the main. Now define a calc object, make a variable of type calc. This is the variable type. Now the variable name, can choose freely, equals new calc. Then you need, now you're calling the constructor. It takes 2 parameters. You need round parentheses, 1 and 1 maybe, 1, 1. Yeah, semicolon. Now we're calling increaser3. It takes a calc as parameter. And the next line we print calc add again. X dot save and run. So what happened now is in line 5, you define a new object of type calc, a variable which is an object of type calc named x. Then you call the method increaser3 with your x. And this method sets left to 8. And in line 7, you print the result of add. And now left is 8 and right is 1, so it should print a 9. The difference between the primitive type and the object type is primitives. The value is copied, and if you pass an object as parameter, only the reference of that object is passed. So it works on the same memory. So primitives, if you have parameters that are primitives like int, char, boolean, etc., the value is copied to the function. And if you have functions or methods with an object, then only the pointer to the object is moved around. So in line 7, it is printing the X stuff. And in line 16, it is also working on the X stuff. Or maybe rephrased, in line 15, the parameter calc is named num, but it's the reference to your variable X in line 5. So incrasa 3 works on the same memory as line 7 or line 5. Primitive variables are copied and object variables are passed by reference. Okay, so maybe we can do a little exercise. I want you to create a method, maybe line 18 new, make it public static boolean, name it isPrime, and it takes a parameter of primitive type int, name it n or num, and I want you to implement a function that checks if num is a prime, and it returns true if it's a prime and false if it's not a prime. And for that, you need kind of loop. You need a loop. Write the curly braces for the method body, curly braces. So we are now checking if num is a prime, and we do this with a for loop. You write for normal parentheses, round parentheses. Now you need curly braces behind this. This is the loop body, and the for, the parameters, you can say, you type for int I equals 2, semicolon, I smaller than num, I smaller num, semicolon, I plus plus. So this is, the for loop works like this. You have 3 statements. The first statement is int I equals 2. This is the initial statement. This is like if you had it without the for. It's just the initial statement. The second statement, I smaller num, is a condition, and the loop is executed as long as the condition is true. So as long as I is smaller num, it does the loop body, which is empty now. And the third statement, I plus plus, is executed after every round. Maybe line 20 new, print out I. System out print line I. And in your main, line 8 new, in our main, call the method. Yeah, and call it with 20 maybe, isPrime with 20 as parameter. And run it. We have defined line 90 shall return a Boolean. And now it complains this method must return a type Boolean. So we do line 23 new, return true. And now run it. So it's now printing the numbers from 2 to 19, because when it's 20, the loop stops. Okay, so in line 22 new, int m equals num modulus I, percent sign is modulus. It's the rest of division. So if you do 3 modulus 2 is 1, 4 modulus 2 is 0, 5 modulus 2 is 1, or 8 modulus 5 is 3, because the rest of the division is 3 then. No, this is the modulus operator. It's the rest of division. Num modulus I, semicolon. And maybe print m in the next line. Run it. For example, call it with 20. So So for example, the 18, 20 modulus 18 equals 2. 20 modulus 19 equals 1. 20 modulus 20 would equal 0. And we can check if it's a prime, because if m in line 24 new, if, round parentheses, m equals 0, and you need a double equal, I think. One equal is an assignment and 2 equals is a comparison. If m equals 0, and this is an if condition, and then the body, if body is also curly braces, that's an if condition, and inside the round parentheses you type the condition, and if the condition is true, then the condition body, the if body, is executed. And here we return false. If it's modulus 0, it's not a prime, we can return false, it's not prime. And now in the main method, go to your main method, to the top, more, in main. Line 3 is your main method. Maybe delete everything again. Delete this. And in main also clean up. And line 5 new, Boolean is prime equals, now we call the method is prime. You need round parentheses for parameter. Now think of a number, not too large maybe, okay, semicolon. And next line, print out the is prime variable. Run it. You see now it's checking the 2, the modulus is 1, it's checking the 3, the modulus is 0, it's not a prime. Let's check a prime, let's check the number 2, try 2, run it. It's a prime. Let's check 3. Now it's actually checking the 2, modulus 1, okay, it's a prime. Now check 4. Not a prime. It's checking 2, modulus is 0, not a prime. So this is a working algorithm to check if something's prime. Please open a browser. Project Euler. EULER. Go to archives, please. Number 1, multiple of 3 or 5. I want you to solve this problem in Java. So we want all numbers that are multiples of 3 or 5. For example, 3 is a multiple of 3, or 9, or 6, 12, 15, or of 5. So 5 is a multiple of 5, 10, 15, 20, 25. And if you look at numbers from 0 to 10, which are multiples of 3 or 5, this is 3, 5, 6, and 9. These are all numbers below 10 that are multiple of 3 or 5. And if you sum them up, 3 plus 5 plus 6 plus 9, you get 23. And now you shall do the same, not until 10, but until 1000. So you basically did a for loop to 1000, do a bit mod, here modulus, then you need to add a bit up.
Here we put 1000.
This is the initial statement. You set the starting value. Yeah, this is the end value, 1000, looks good. And in line 9, you start not by 2, but by 1. Maybe line 8, change the return type. Change the return type from Boolean to int. Line 9, I would say line 9 new, int sum equals 0. Then delete all the for loop body, delete everything from the for loop. In line 13, return sum. And now we need to implement the for loop. And now you need to check if I is a multiple of 3 or 5. So you need an if. There in the round braces you put the condition and the curly for the body. Okay, and the condition is if I modulus 3 equals 0. double equal for comparison. If it's divisible by 3, then you have to add it to the sum. Now you do sum equals or plus equals, yeah? And now you need to add what?
DI.
Correct. And now we need the same for 5.
So it will be the same here, but we edit this.
Correct.
Five.
Run it. Should crash. Line 5. At demo main Java 5. So you define a Boolean and assign it to the return value of the isPrime function or method. You are creating a variable named isPrime and you are assigning it to the return value of isPrime method. And the isPrime method is returning what?
Int.
Yeah.
So.
And you assign, yeah.
Int.
Correct.
Let's try.
Maybe go to Euler again. There you cannot enter it there. I think it's correct.